Thanks for coming to the talk. I know there's a lot of good stuff on the agenda. I appreciate you coming to this one. I am Dan Chuparkov. I have been working in software for about 24 years now, done a bunch of different things. You can find me on the internet pretty easily. I'm the only Chuparkov that understands search engine optimization. So we're going to go through three things today. One, I'm going to start with some basics of data science, just to make sure that we're sort of leveling the playing field. I want to make sure that everyone here, regardless of your job, has a basic understanding of some of the more complex things like neural nets and stuff like that. So we're going to dive into that. I also am going to dive in a little bit more to machine learning and neural nets because I think they're increasingly more and more important and interesting. And then finally, we're going to talk about the partnership between humans and machines because in a bunch of talks this year so far, I've heard people talk about how important it is to get the balance between algorithms and people making decisions at the same time, how important that balance is. So these are the three talks, and let's get started with the Data Science 101 part. Okay, so as you are listening to the rest of this talk, I hope to have some content for all of you at different ends of the spectrum. One of the things I can't recommend enough is this podcast. It's a podcast called Linear Digressions. It's from a former coworker of mine who has done some amazing things, and one of her coworkers, Ben and Katie, they are running a podcast. It's weekly. It's like 15 minutes, pretty short. It's one of the only podcasts that I've actually backed up and listened to every episode for. I've only done that twice. And it's 15 minutes, and it's been going on for about a year and a half, and there's some really great content in it. Whether you're just getting started or whether you're pretty advanced and want like white papers that just came out last week that you want to read, this talk covers it really, really well. So definitely recommend this. Okay, so the next thing I'm going to talk about a little bit is descriptive analytics, because it's sort of where we started, where I started in 1998, what we could do in the world. We're still doing it a lot. It's still incredibly valuable. Descriptive analytics typically starts with some sort of structured data, right? All of us have some data somewhere in a database. It's in rows and columns like this. Maybe you look at it in Excel spreadsheets. Maybe you look at it with more complex like SQL queries and stuff like that. But it always starts with structured data. And I want to call out how structured this is because I want to contrast it with unstructured data in a few minutes. But this is what structured data looks like, and it's called structured data because it's always in the same format. When you have a column that's called user ID, when you look down that column, it's either going to have user IDs in it or it's going to be blank, right? It's not going to have a bunch of other random stuff in it, and that's really, really important. And increasingly, as we start dealing with stuff like photos that were uploaded or captured or sensors from a self-driving car, the structuredness of that data is starting to change dramatically, and so understanding that contrast is important. So one of the ways teams since about 2003 have been visualizing and looking at that structured data is with a tool like Tableau. Tableau, pretty good tool. It's very mature at least. It has lots and lots of functionality and features. So if you're trying to visualize complex things and share it with your team, Tableau can help you do that. Not recommending Tableau. I have no affiliation. I just want to point out the things that are available to you. So once you sort of outgrow Tableau and Looker and things like that, you may want to start looking into D3. So D3 is really, really awesome. D3 is more like a community than a thing. D3js.org has lots and lots of custom JavaScript-based visualizations. You can literally go there and just like grab the code for this like awesome bar chart visualization thing with the animation and just copy and paste and put it in your own thing and connect it to your own data source. There are hundreds of pre-made visualizations, and so if your team or your product or your customers start to tire of the same like bar charts and pie graphs that we've been looking at for like 30 years, D3 really helps you start to take that to a whole nother place. It's really awesome. So that's what you do with structured data, right? You get a bunch of structured data in a database, and then you visualize it and share it, and like look at these graphs and try to infer trends from it, right? At some point, you'll start using things like unstructured data. You'll get a bunch of customer requests in a big repository from help tickets or surveys or whatever you get. Or you'll have image recognition from some cameras or sensors or things like that. Unstructured data is called unstructured because it usually has some sort of huge block of like text or image data in it. Like if you were putting the Declaration of Independence into a database, it would be a pretty boring database. It would have like one long row. And one of those fields, the body of the declaration, would have a huge amount of stuff in it. And querying the body of the declaration would just give you the body of the declaration, and that's in no way useful. What you could do instead is grab all of this text and build like a topic model out of it. right? A topic model is just a look at all the text and then some analysis that shows you, like, what is this really about? And I'm not going to analyze this one because that's not as useful as this one. This is a basic topic model of this year's South by Southwest. So these are the words most frequently used in talk titles only, not description, at this year's conference. And so I've been coming to this conference for like 10 years, and I do this every time, just basic text collection and a tag cloud. And this tells me incredible things like my talk should be called Designing and Building for the Data Science Future, right? If you do that, I promise you will have a completely full room. So data science is like magic, right? Okay, so those are sort of the basics of structured data and unstructured data and how to visualize and what you can do with it. Now let's dive in a little bit more to some of the more complex things. So advanced analytics is typically the name for stuff that goes beyond descriptive, right? So descriptive analytics, from the Gartner quote at the beginning, was a look at data, things that have happened already in the past, right? Looking at what's going on in your customer base or with your products or with your sales volume or any of those things and displaying it and looking at some sort of trends, right? Now, trends are not predictive, right? Trends aren't looking into the future unless the future is exactly the same as right now, right? And so where some of the advanced analytics things take this to a whole nother level, so you can start answering the question, what can we do to make this happen, right? Now, predictive analytics and prescriptive analytics are sometimes used interchangeably as synonyms. They're slightly different. I like the term prescriptive analytics because it's not just predicting the future, but it's also making some sort of recommendation about what you should do, given that that future is likely. And so prescriptive analytics is where I encourage each of you to start migrating to, if you're not already there, and I'll tell you how you can start doing that. So really common way to start tackling machine learning, a way to think about it at least, is with machine learning, you always have some big list of stuff, right? Like in this case, I've got shapes. There's different shapes. There's different colors. Some of them are outlined. Some of them are not. And I'm trying to understand that collection of shapes and predict what might be true in the future with other shapes, right? So in this case, there are no pentagons in that list yet. And so what I'm trying to do is build some sort of a question answering algorithm that could tell me something about this shape I've never seen before. Now, this list of shapes could be a list of customers that have made purchases in your store, or a list of customers that like do something interesting in your software. It could be a list of things on the road with the self-driving car coming at it, right? Like all of those are tackling this same exact problem. You always have a big list. You're trying to understand it so you can predict things that you haven't seen yet. There are two kinds of machine learning that you're going to be tackling. One kind is called unsupervised learning. That's where I have a big list and I don't tell you anything about it. Your algorithm just looks at that list and tries to find patterns. You might build an algorithm that looks at that list and says, I've got some things outlined and some things that are green and some things blue and some things that are red. I did this once for a large customer, like sporting goods chain, and they were analyzing, like, you know, who are the golf and tennis pros and who are the fitness nuts, and like that's a common kind of automatic clustering. Now, the software doesn't know if like group 1 is better than group 4, right? It might know properties about it, like maybe the total sales volume or the frequency, right? And those might be intuitively good to you, but your algorithm doesn't know that yet. Your algorithm's job is just to make those clusters, and then you can figure out what to do with them. The other kind of machine learning you could do is called supervised learning. And with supervised learning, you're giving it the right answer in advance, at least for a small subset of it. All right? So now here I'm saying, like, this is my full list of customers or my full list of users of my product. And these were the 5 users that did something that I really, really liked. All right? And so with supervised learning, then what your algorithm is trying to do is figure out, like, what does this list have that's different from the other things in the list that aren't in my final set, right? And that's called supervised learning, because what I'm doing is I'm telling the algorithm in advance what stuff I like. Now, you typically do that by loading a training set into your algorithm, right? And the training set usually looks like this. It's just that same list of stuff, but they've been labeled. You've got either, you know, positive outcomes or negative outcomes, or good or bad or true or false. Whatever you're looking for, your training set is going to look like this. It's usually some subset of data, not the complete universe of data, but subsets of data are becoming very, very large now. right? We have companies that are doing, training sets that have billions of rows of stuff in them, right? And what they're trying to do is understand everything that they've seen so far in order to predict what might happen tomorrow. So your training set is not necessarily just a little tiny set of 100 rows or 1,000. That's training set. Now, once you understand the basics of machine learning, then you might start using some of these tools to do stuff with it. So I'll talk a little bit about some of the tools we use on our teams these days. One of them is called R. R is a programming language. There was a programming language called S, and it had something to do with statistics. And some people decided there should be an R. So R is a very useful tool, and it's a useful programming language for this because it has statistical library packages already built in. So you can do things that are pretty useful. So if you hear people on your teams talking about R programming or Python or things like that, what they're talking about is the programming language that they're doing stuff with. People typically program R in RStudio. You could get it from rstudio.com. It's pretty useful. You'll start hearing about it more. Once you start building some interesting things in R, you might start sharing them, either with other developers on your team or with your stakeholders, or maybe even with your end users through the web. RShiny is basically a web hosting package for R, right? Built right in, so that if I have a data scientist that made some new visualization in R, and it looks really interesting, and we want to spread it out to the team and see, should we pursue this more? They can put it in Shiny really, really quickly without having to go to IT and set up a web server and do all these, all the things you would normally have to do to make a front-end developed web page that you can use to share. Shiny's pretty useful. You can get rapid deployment of web enabled visualizations very, very quickly. And they look really, really awesome. These are some samples from the RShiny or from the shiny.rstudio website. We'll look into it more. Similarly, there's the idea of a notebook. So data science notebooks are similar to what we were just talking about in RShiny, where I have a data scientist or some analyst or someone that has made something that they want to share. And a notebook sort of works like any document, like Excel. I could do a bunch of stuff in Excel and then send that spreadsheet around to 9 people and they could look at it. Jupyter Notebooks works like that. There used to be something called IPython Notebooks. You can still probably get it. It branched. So Jupyter Notebooks and IPython Notebooks are they have the same origin. It's a really useful tool for building visualizations that look like this. And they're sort of like a notebook, right? Like you have actual code and you have documentation that describes what it's doing and a visualization all together in one so that a person can read and you can type what your thought process was when you made that visualization and share it out with your team. Really, really, really useful. Jupyter Notebooks works really well with Python, and that's a little bit limiting. So what you'll see now is there's something called Zeppelin Notebooks, which is a little more expanded. So a little more recent in its development. Same sort of concept where you can take some visualizations and get them quickly into a shareable notebook that you can send out to your team and do whatever. But it works with other languages instead of just. So pretty cool. There, zeppelin.apache.org is where you can find it. Now you've learned how to do a bunch of things, some structured data, some unstructured data. You have a basic understanding of what machine learning is, and you might want to learn more and get some data to play around with so you can start taking your data science to another level. One of the places I would recommend is Kaggle.com. Some people have heard of Kaggle because it's this competition place, right? You can go to Kaggle, you can enter a competition and compete against other data scientists that are doing complex things. But you can also just go there as a novice and download some data set that gives you something interesting, like bus stop wait times in the city of Chicago. You can just get really, really interesting stuff from here. And so as you're learning how to be a data scientist, or as your teams are trying to explore with more kinds of data, Kaggle is a good way to get some sample sets of data to play around with. You can also see what other people are doing with it so that you can start seeing how they're solving problems or what's possible in the world given the data sets that we have and the tools that exist right now. So Kaggle's pretty cool. I encourage you to play around and see what's going on. Okay, so next we're going to talk a little bit about neural networks. Neural networks are sort of an advanced form of machine learning, really, really helpful for things like image recognition. I'll show you more about that in a second. But neural networks are called neural networks because they sort of work very similarly to how our brain works. I won't go into that in too much detail, but that's where the name comes from. And this book, On Intelligence, from Jeff Hawkins, is the is a really good book on how your actual brain works. If you read this book, it's a really easy read, not too complex. He's a great writer, and he explains like how some of this works. And then when you look at neural nets, it'll make a lot more sense. So neural networks are really, really awesome for image recognition pictures, because like understanding whether you're looking at a muffin or a puppy, it's like really hard, right? And like, if you were trying to write a program that could do this manually by saying like, look for the nose and know that it's a nose because, I don't even know, it has 2 holes in it and maybe it glistens more than a blueberry. Like, if you were trying to write the rules of a program that could do this, it would be horrible. You'd be terrible at it. Neural networks can use a problem like this and figure out how to solve it in a really, really interesting way that works much, much, much better than a program you would manually write. So it's pretty neat, and we're going to do a little experiment today in neural networks. So if you like Google what is a neural network on the internet, you're going to find a bunch of garbage. Like you'll have 1,000 pictures like this. That is how it works. But like that doesn't explain very much. And so what I wanted to try to do today is sort of explain sort of what's happening. We're going to simplify it a little bit so that we can actually fit it into an hour. And we're going to actually build our own neural net right now with people. I'm going to need 5 volunteers like in a second, like right now. I promise this won't be hard or scary or embarrassing, but 5 people maybe from the front of the room or an aisle come and stand next to one of these whiteboards. One guy. Okay, all you're going to have to do is look at a couple of pictures and decide like what's different between group A and group B. One more back there. Oh, I think we've got him. He's already perfect now. Now he's first. Okay, awesome. So each of you are going to be a layer in a neural net. We'll start with layer 1 over there, and we'll get to layer 5. Right? Each of you is going to get your own set of pictures, right? And we'll start with you with this set of pictures. So what you're trying to do is think of a rule that works for the set of pictures over there on the left that doesn't work for this set of pictures on the right, right? So something that's true of all those people or all those things over there that isn't true over here. And when you think of something, write it down on that whiteboard. Sweet. Okay, awesome. Layer number 2, something that's true about the left that's not true on the right. Yeah, somebody can help her. Yes, awesome. Oh, that's it. Awesome. All right, cool. Yeah, so here's one of the interesting things about neural nets is like the layer of the neural net just gets to decide what they think is true based on what they see, right? So this may or may not work at the end, but it's going to be a neural net. Okay, layer 3. What's true about the left set of pictures that isn't true about the right? Sweet. All right. And then layer 4, what do we have? I don't know if you guys knew this, but all seals are hipsters. Okay, layer 5. 5 and 1 are probably. Awesome. And maybe write small on there because all things will have a size. That will always be true. Sweet. Okay, awesome. Now, I cheated a little bit here. Normally, if you were building a neural net for pictures of cats, you would only look at pictures of cats, right? Your whole training set would be a bunch of cats in a bunch of different ways and a bunch of things labeled not a cat. I cheated a little by giving you some things that were also not a cat because I didn't want your bias of understanding of what a cat is to influence what you wrote. And 2, I wanted you to get to discrete answers. Okay, so what I think we did is built a neural net that can identify pictures of cats. So let's see if it works. So we're going to run the neural net and decide, all of you, like raise your hand if this thing passes your test. Is this a while? Okay, so we have, are you 5? Are you up or down? Okay, 5. Okay, so what I think we have is an 80% confidence that our neural net thinks this is a cat, right? It won't pass every test every single time, but 80% confidence is pretty high. Okay, let's do this one. Raise your hand if it passes your test. Okay, pretty close. So we have 100% confidence that this is a cat. So with more training data, we might have solved this problem a little bit better. But it's pretty close to a cat. Okay, how about this one? 0% confidence that this is, okay, so if the first one or the second layer had thought quadruped, 4 legs or whatever, this would have had a 20% success rate, right? So neural nets will work like this. You'll have some confidence, it might be small confidence, but it will pass some of the layers of your net test. So an important thing is when you're sending pictures through a neural net like this, you can't, just because you get like one failure, you can't throw it out. Like let the other layers of the neural net like process their tests. Because you might fail some early test, like is it an animal or not an animal, right? And maybe it's a little bit hard to figure that one out, but the other 4 clearly pass it. So let's see, I think I have one more. Yeah, one more. One more, raise your hand if this passes. Sweet, okay, so that's good. So 60% confidence in we need more training set data to identify the difference between tigers and cats. And so that's how a neural net works. So I think you guys can sit down. Thank you very much. Really awesome. Okay, so if you think neural nets are awesome and you want to have some more fun with them, go to this, either just search for it on Twitter or actually follow the account. It's called Pick Describe Bot. And what they're doing is just finding random pictures and using a image recognition neural net to try to identify what's in the picture. And it's still a little immature in its ability to do that. So this is a couple of giraffes sitting on a table, obviously. There are some really, really awesome ones. I won't share more with you, but. Okay, so that's the basics of machine learning, neural nets, some of the advanced analytics topics that we do, like things we do in R or things we do in Zeppelin notebooks. Again, all these links to resources will be on SlideShare, and you can see it there as I'll upload it like in another day. The next thing that we're going to talk about is how to take that data and make products that work well in the world, given that there are still a bunch of people in it. There are lots of companies that are making some very sophisticated things with machine learning, with neural networks, with image recognition and sensors that are collecting data every second and streaming it into databases in real time. You will be able to make some very, very, very sophisticated things. I don't know if any of you heard about the story. It's now old, so you've probably heard it 100 times. In 1996 or something, IBM made a software program that could beat Garry Kasparov in chess. Huge accomplishment for the time. They were processing like millions of rows of data, millions of options of chess moves with every play. Really, really, really interesting. And that was a huge milestone for computing. But just a few years later, the other chess match that you don't hear as much about was a freestyle tournament between people and computers together matched with grandmasters. And so in that freestyle tournament, the people and computers beat the grandmasters almost every single time. And the reason that's happening is because computers are really, really good at like taking all of the possibilities and figuring out what they are, and then putting them in a right order. So curating is step 1, and then prioritization is step 2. But they're not good at judgment yet. They don't understand all of the context in which people will make decisions. They don't take risks as well, at least. And so the human-computer pairs almost always win the freestyle tournament. And you'll see lots and lots of other examples of this human-computer pairing happening in the world. And so my advice to you, like the takeaway from this talk is, as you learn how to do more data science, resist the urge to make the decisions for the people. And I'll explain what that means a little bit more here. But when you're building stuff, even when you make really, really, really sophisticated algorithms that can do lots and lots of things dramatically faster than people, give your people some levers and controls to tweak and adjust things and change their prioritization. Like the kinds of things I wanted a month ago might be different than the kinds of things I want now. And your algorithm, no matter how good it is, it's not going to be right every single time yet. Maybe some amount of years into the future, we will get to that place. But right now, it probably isn't. An example. One of maybe the most sophisticated team on the planet, processing information, in incredible amounts of volume. They know almost everything there is to know about things people search for on the web. And when you go to the website, most of us just type in the address bar now, but if you go to google.com, you still get these two buttons, right? Who, when they're searching, goes here and just clicks the I feel lucky button and lets Google pick the result for you, right? Nobody would do that because we vastly prefer to just get a top 10 list and pick number 3 or 2 or 27, right? Because Google's really, really good at deciding what the number 1 option might be. But it still doesn't pick for us. It lets us pick, right? Because Google knows, regardless of how much information they've captured and is cookied, and they have my search results in my Gmail and whatever else they've got, they still let me choose, right? Google looks at their job as curation and prioritization, and they let us make the decision. And you can see that in more things. Like this is a Google search for what is the top Google search? Google knows the answer to this question, right? But still, they give me 529 million options, right? If they're not an authority on that, who is, right? So my main recommendation with this is prioritize what you're doing for your users. Don't choose for them. Your job is to curate or maybe even generate a bunch of options for users and then present it to them in a way that lets them easily choose. And then let users sort of figure out or sort of let you know how you're wrong and how you're right and what they would choose. And then you get to learn from that over time. I'm going to share this video. I have no affiliation to Autodesk, but it's pretty awesome, so I wanted to share. This video is from some software that they have, but the concept is called generative design. And I'll play it for you now. It's like a minute.
What if you could come up with thousands of options for a single design without drawing, all of which meet specific goals set by the designer? And from those options, pick the one design that delivers on the most important criteria, the design you couldn't possibly have imagined. This is generative design, a technology that harnesses massive computing power, creating forms with precise amounts of material only where needed, achieving maximum performance while wasting nothing. But generative design can be about much more than simply turning out alternatives. Prototypes can be scanned and equipped with sensors that provide real-time performance data that can be looped back into the design process, so the object, in effect, co-designs itself. And depending on the material and method of manufacture chosen, the software can optimize the design for those choices. In its search for the optimal design, generative design creates complex forms that would otherwise be impossible to make using traditional manufacturing methods. Now with advancements in material science and the ability of 3D printers to print metal, companies like Airbus can create forms like this airplane partition panel that's half as light and just as strong. The result? Significant reduction in fuel costs and CO2 emissions. The things that have limited us in the past, software, materials, manufacturing, no longer do so. With generative design, the world can look and perform any way we want it to. This is the next stage in the evolution of design, and it's happening now.
Cool. So I share that video because I think it's a really, really good model that all of us can follow. Even if when we say design in our industry, we don't mean design of a product that gets built into a physical thing. If we're building a website, or if we're building some product for users, or we're building an algorithm that processes some large amount of data, we can follow a lot of the things that we saw in that video. And I want to call out a couple of them first. So one of the screens we saw was this crazy matrix of stuff. And what this is a computer-generated list of options for that user. So as a designer, an architect, industrial design person, they would have manually drawn these things before and maybe considered some of them and sent some of them over to structural engineering, and they would have evaluated them. And all that takes time and process, and they only consider a small handful of the actual possible. What Autodesk is doing here is they're just using machine learning and neural networks to programmatically create all the possibilities and just put them in a list. And that algorithm isn't deciding which of these is the best. The next screen that I want to show you is how they actually decide what's the best. And this was half a second in the video, but it's maybe the most important thing. And it's to the side of the screen, there are a bunch of, it's a little hard to see, but there are a bunch of variables like amount of stress and the displacement value and like how much material usage is there. And the designer gets to like change these levers and say, okay, well, to minimize stress a little bit more, I'm willing to spend a little bit more on materials or materials cost or whatever, right? These levers of control over on the right here are really, really, really important, especially as you start making complex algorithms that do complex things. Let your users use their domain experience to help you get your algorithms right? Let them show you what their balance between cost and weight and, stress might be. So the other thing that it did is once the designer used those levers and identified two of their most important pieces of criteria, right? Like stress versus weight. Even knowing all of that, the algorithm still doesn't pick for them. They give it in a really, really useful matrix and lets the user say, okay, well, I want the absolute heaviest, I don't know. I want the absolute heaviest thing, and I don't care about stress. Or I want one of these in the middle that sort of maximizes both of those at the same time. The designer gets to help make this decision. The algorithm's job is just to present all the information to the designer so that they can make the right decision. I propose that like everything every one of us is building could follow this model. And in the next some amount of years, while we're still refining our machine learning algorithms and getting better at creating neural nets and having more sensors and information collection points in the world to make all these things better, this style of curation and prioritization and then partnering with your users and then learning how it happens over time is the way we can all make software the best. We see this again in Google. We see this again in Netflix. There are lots and lots of cases of this happening. Google here almost never just says, here's the way you should drive there, right? It says, here's our preferred way, our number one way. I live in Chicago, and this is the suburbs of Chicago, and it tells me, to take that blue road. But I might know, I don't really want to pay the $6 toll every single time. So sometimes I'm going to take the gray road, even though it's $5 or 5 minutes longer, right? Google almost always does this for you. They always give you choices. Netflix also does this. They have a really, really good understanding of what we watch, the content that we consume, what we want to see next, even what shows they should make next, right? They have a better understanding of that than maybe anyone else in the world. And still, they don't just give you two choices and say here's what you should watch tonight, right? They give you lots of choices. Netflix has about 600 different user types. Each one of us falls into one of 600 buckets. And each of us on top of that has some understanding or some cookie and previous behavior and things that we've watched. And all of those things are factors that would make Netflix really, really good at just picking the next show for us. They only do it one time, and that's when you're done with something that you just watched and you're binge watching a series, right? They give you 5 seconds to decide if you want to watch the next episode, right? And they just start auto-playing it in 5 seconds. This is the only time they make the decision for you, and it's really, really contributed to the binge watching problem in America. But one thing that's important is they let you turn it off. If you don't like that, right, you can just go into settings and say, I don't want you to play the next episode automatically. Companies like Google and Netflix never make the decision for you. And if they do make the decision for you, they let you adjust how it's being done. And so as you are building things for your users, regardless of how sophisticated you think your data science is, understand that you don't have all the context yet. And so use these levers and controls to help get it right. And resist the urge to make those decisions for people. And as you're doing that, just remember, your job in software is to do these 4 things. Every single time, no matter what you're building, you're curating or generating all of the possibilities, and you're prioritizing them and putting them in a really intelligent list. And then you're partnering with the users to let them tweak and adjust and make the right decision. And then you're learning from everything that happened in stage 1, 2, and 3 so that you can loop around and do stage 1 again with more insight than you did. So that's it, and that's the talk. This will be on YouTube slideshow.